Welcome to Mathematics 1. I am Professor CHEREF Oualid, and today's lesson is about real functions of one real variable. At the end of this course, the student will be able to find definition domain, distinguish and compose functions, know what a periodic function is and the properties associated with it, study function preemption and distinguish whether the function is even or odd and take advantage of its confusing properties. Learn about a bounded function and ways to use it, to study the meaning of variations of functions and the ability to analyze and interpret curves. Real functions of one real variable involve functions where both the input and the output are real numbers, and the function is determined by a single real variable. Definition: a real function of one real variable is a rule that assigns a real number to each real number input. Essentially, it's a process where you input a real number, and the function gives you another real number as the output. Domain and range. The domain of a function is the set of all possible input values for which the function works. For instance, a function that involves taking the square root of a number is only defined for non-negative numbers. The range is the set of all possible output values. For example, for a function that squares a number, the output will always be non-negative. Graphical representation. To visualize these functions, we plot them on a graph. On this graph, the horizontal axis represents the input values. The vertical axis represents the output values. The shape of the graph helps us understand various characteristics of the function, including how it changes and the range of values it can take. Operations on functions involve various ways to combine or modify functions to create new functions. Here's a simple overview of common operations on functions. 1. Addition of functions. When you add to functions, you create a new function, where the output is the sum of the outputs from the original functions. For example, if you have two functions, one that squares a number and another that doubles a number, their sum will be a new function that combines these operations. Specifically, if you input a number into this new function, it will give you the result of adding the square of that number to twice the number. Example, if one function gives you the square of a number, and another function gives you twice that number, adding these functions will result in a function that gives you the square of the number plus twice the number. 2. Multiplication of functions. To multiply two functions, you create a new function, where the output is the product of the outputs of the two original functions. For example, if one function doubles a number and another function adds 1 to the number, multiplying these functions will result in a new function that gives you the product of the number doubled and the number plus 1. Example, if one function doubles a number and another function adds 1 to it, multiplying these functions will give you a new function that outputs the result of the number doubled times the number plus 1. Upper bounded, lower bounded, and bounded functions refer to the constraints on the range of values that a function can take. Here's a straightforward explanation. Upper bounded function. A function is upper bounded if there exists a real number that is greater than or equal to every value the function can produce. In other words, the function's outputs do not exceed a certain maximum value. Example, consider a function that represents the height of a person above sea level, but it is known that this height can never exceed 10,000 meters. This function is upper bounded by 10,000 meters because no output value goes beyond this upper limit. Lower bounded function. A function is lower bounded if there exists a real number that is less than or equal to every value the function can produce. This means the function's outputs do not fall below a certain minimum value. Example, imagine a function that describes the temperature in a location where the temperature can never go below -50 degrees Celsius. This function is lower bounded by -50 degrees Celsius because no output value goes below this lower limit. Bounded function. A function is bounded if it is both upper bounded and lower bounded. This means there are both an upper limit and a lower limit on the values that the function can produce. Essentially, the function's outputs stay within a specific range. Example, if you have a function that models the average daily temperature over a year in a region where temperatures vary between -10 degrees Celsius and 35 degrees Celsius, this function is bounded. It has a lower bound of -10 degrees and an upper bound of 35 degrees. Summary. Upper bounded. The function's values are always less than or equal to a certain maximum. Lower bounded. The function's values are always greater than or equal to a certain minimum. Bounded. The function's values are within a specific range, having both an upper and a lower bound. Increasing and decreasing functions describe how the output of a function changes as the input changes. Here's a clear explanation of these concepts. Increasing function. A function is called increasing if as the input value increases, the output value also increases. In other words, if you have two input values, where the second input is greater than the first, the output corresponding to the second input will be greater than or equal to the output corresponding to the first input. Types of increasing functions. Strictly increasing. A function is strictly increasing if, for any two input values, where the second input is greater than the first, the output corresponding to the second input is strictly greater than the output corresponding to the first input. There are no cases where the output values are the same for different inputs. Example, the function representing the total amount of money you have as a function of the number of hours worked is typically increasing. As you work more hours, the total amount of money you have increases. Decreasing function. A function is called decreasing if, as the input value increases, the output value decreases. In other words, if you have two input values, where the second input is greater than the first, the output corresponding to the second input will be less than or equal to the output corresponding to the first input. Types of decreasing functions. Strictly decreasing. A function is strictly decreasing if, for any two input values, where the second input is greater than the first, the output corresponding to the second input is strictly less than the output corresponding to the first input. There are no cases where the output values are the same for different inputs. Example, the function representing the amount of fuel remaining in a tank as a function of the distance traveled is usually decreasing. As you travel further, the amount of fuel left decreases. Even, odd, and periodic functions are classifications based on the symmetry and behavior of functions. Here's an explanation of each type. Even functions. A function is called even if its graph is symmetric with respect to the vertical axis, the y-axis. This means that if you take any input value and it's negative, the function will give you the same output for both. Essentially, the function's output remains the same if you reflect the graph across the y-axis. Example, consider a function that squares a number. If you input the number 3, you get 9, and if you input -3, you also get 9. This function is even because it produces the same result for both positive and negative inputs. Odd functions. A function is called odd if its graph is symmetric with respect to a rotation of 180 degrees around the origin. This means that if you input a number and also input its negative, the output for the negative number will be the negative of the output for the positive number. Essentially, the graph has rotational symmetry around the origin. Example, consider a function that cubes a number. If you input the number 2, you get 8, and if you input -2, you get -8. This function is odd because the output for -2 is the negative of the output for 2. Periodic functions. A function is called periodic if it repeats its values in regular intervals. This means there is a specific interval, after which the function's values start repeating. This interval is known as the period of the function. Example, consider the function that describes the sine of an angle. The values of this function repeat every 360 degrees. This means if you look at the function from 0 to 360 degrees, it behaves the same as it does from 360 to 720 degrees, and so on. Summary. Periodic functions. The function's values repeat at regular intervals, showing a repeating pattern over a set period. Remember, curiosity and interaction are key, so don't hesitate to ask questions and delve deeper into the material. Welcome, and I wish you an enriching and enjoyable educational experience.